Hi. In part 1 of the video on indices that we did, we defined what an index is, and we also saw that indices is actually the plural for the word index. Now, we went ahead to state and illustrate the 8 laws of indices. Now, in the second part of the video, we tried to use the rules of indices or the laws of indices to simplify exponential or indicial expressions, or to evaluate sums by use of indices. Now, in this video, we are going to use the 8 rules of indices to solve exponential or indicial equations. So let us solve the exponential equations below, and in solving them, we will only use the rules of indices. Remember, in solving these equations, we assume we have no knowledge of logarithms, and therefore we will not use logarithms to solve them. Now, problem number 1, 9 raised to power x is equals to 81. So we are supposed to find x. Now, to solve this problem, we will want to see how we can express the right hand side as a power of 9. So we can rewrite the problem as 9 raised to power x is equals to, we know that 81 can be written as 9 squared. So we can write the right hand side as 9 raised to power 2. And using the 8th rule of indices that says if m raised to power n is equals to a raised to power n, then m is equals to n, we can see here that we have a similar situation where two numbers that are equated have the same base and different powers. So if the bases are the same, then we expect the powers to be the same. That means that x is equals to 2. And that is your solution. Now, the second problem says that 2 raised to power 3x minus 4 is equals to 1 over 32. Now, again, since the left-hand side is a power of 2, we could think of trying to express the right-hand side as a power of 2. Now, we know that 32 is 2 raised to power 5. So we could rewrite the problem as 2 raised to power 3x minus 4 is equals to 1 over 2 raised to power 5. Again, from the laws of indices, we know that a raised to power minus m is equals to 1 over a raised to power m. So if you make use of this rule here, then you could write the right hand side as 2 raised to power minus 5. So that we have 2 raised to power 3x minus 4 is equals to 2 raised to power minus 5. Now again, we have a situation like we had earlier. If a raised to power m is equals to a raised to power n, then we expect m to be equal to n. So we have a similar situation here. Since the bases are the same, we expect the powers to be equal. That means 3x minus 4 is equals to minus 5. Now, then from here, you simply need to isolate the variable x by adding 4 to both sides of the equation. So you can add 4 to this side, add 4 to this side, then you'll have 3x plus 0 is equals to minus 1. Now, how do we eliminate 3 from this side? We can simply do that by dividing 3 by both sides, so that we have x is equals to minus a third. And that is your solution. Now, looking at problem number 3, we realize that it is more or less like problem number 2. The left-hand side is a power of 5. The right-hand side is a power of 25, meaning that we could try and think of how to rewrite the right-hand side as a power of 5. Now we know that 25 is the same as 5 squared. So we could rewrite the right-hand side as 1 over 5 squared. Then outside we have our t minus 4. Now, using the power rule, this can be written as 1 over 5 raised to power 2t minus 8. Then, using the laws of indices, we know that a raised to power minus m is the same as 1 over a raised to power m. So, if we were to look at it from the right-hand side, then we are saying 1 over a raised to power m is equal to a raised to power minus m. So, we could write the right-hand side as 5 raised to power 2t minus 8, but with the index negative. So if you simplify this, then we have 5 raised to power minus 2t plus 8 being equivalent to 5 raised to power 3t plus 5. Now again, as we've done in the previous examples, since the bases are equal, then we expect the powers to be equal. That means 3t plus 5 is equal to minus 2t plus 8. Now, if you put the like terms together, then you're saying 3t plus 2t is the same as 8 minus 5. 3t plus 2t is 5t. 8 minus 5 is 3. Isolating t by dividing by 5 both sides of the equation, then we have t is equals to 3 over 5. And that is your solution. Now, let's look at problem number 4. Now, if you look at problem number 4, you will realize it is slightly different from the problems 1, 2, and 3 that we've solved earlier, in the sense that whereas in the previous problems we've tried to express both sides with the same basis, you realize it is not possible to express 6 as a power of 2. How then do we deal with this? Now, recall our rule number 7, which says a b raised to power m is the same as a raised to power m times b raised to power m. Now, using this rule, we can try to rewrite the right-hand side using it. Now, we know that 2 multiplied by 3 is 6. That means we could write 6 raised to power 2x plus 3 as 2 multiplied by 3 raised to power 2x plus 1. And using this rule, we can show that this is the same as 2 raised to power 2x plus 1 multiplied by 3 raised to power 2x plus 1. So we could rewrite the right-hand side as 2 raised to power 2x plus 1 multiplied by 3 raised to power 2x plus 1. And this is the same as 2 raised to power 2x plus 1 on the left. Now, since these two are equal, you will realize that 2 raised to the power 2x plus 1 is common to both sides of the equation, meaning we could actually cancel them so that we have 1 is the same as 3 raised to the power 2x plus 1. Now, if you flip this, then we are saying 3 raised to the power 2x plus 1 is the same as 1. And we know that using the rules of indices, 1 can be written as 3 raised to the power 0. So we have a situation whereby 3 raised to the power 2x plus 1 is the same as 3 raised to the power 0. And since the bases are the same, then we can equate the powers. Now, if you solve for x here, then we'll have that x is minus a half, and that will be your solution. Now, another quick way to think of how to solve this problem is to realize that you cannot equate two different numbers with the same powers unless the power is 0. There is no way 2 raised to the power 2x plus 1 can be equal to 6 raised to the power 2x plus 1 unless the power is 0. So that means outrightly 2x plus 1 is 0, therefore x is minus a half. Now let's look at problem number 5. Now if you look at this problem, you'll realize that it is different from all the problems that we've looked at. However, if we were to write it as 2 raised to the power x everything squared minus 5 times 2 raised to the power x plus 4 is equals to 0, then if 2 raised to the power x was some variable, say t, then this would be a quadratic equation. So let t be 2 power x. So we are going to have t squared minus 5t plus 4 is equals to 0. Let's look for any two numbers whose product is 4 and whose sum is minus 5. Those numbers are minus 4 and minus 1. So if we write this quadratic equation in t, then you're going to have t squared minus 4t minus t plus 4 is equal to 0. Now factorizing this by grouping, we have t into t minus 4 minus 1 into t minus 4 is equals to 0, which is the same as saying t minus 1, t minus 4 is 0. Now, if the product of these two terms is 0, then it means either or both of them are 0. That is the fundamental principle for solving quadratic equations. So this means either t minus 1 is 0 or t minus 4 is 0, meaning that t is 1 or t is 4. Now, remember our problem was a quadratic in x, meaning that we have to look for a way of reverting the solutions so that they are in terms of x. Now, remember we made an assumption that t is equals to 2 raised to the power x, meaning that our t, which is 2 power x, is 1, or 2 power x is 4. If you rewrite the right-hand side here in terms of, or as a power of 2, that would be 2 power 0 using the laws of indices, meaning that x is 0. On the right-hand side, we have 2 power x is equals to, if you rewrite the right-hand side as a power of 2, then you'll have 2 squared, which implies that x is 2 since the bases are the same. So those are your solutions. Now, to check whether you've understood today's lecture or today's lesson, I want you to solve the following problems. Now, if you solve the problems given, then you should get the following solutions.